Now, did you know that our sun is actually green? Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious, can't you tell? In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too, but please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. Oh, by the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The sun just looks white, but technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much. Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars, and still our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs. maybe even 7 dwarfs. When a star like our Sun is about to finish its life, it expands and turns into a red giant, and then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our Sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The Moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. But the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. But we would still be able to survive. We'd have 2 options: to build giant submarines and go down into the depths of the ocean closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it would reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. So, which option would you prefer? Living at the bottom of the ocean in a submarine or on the surface near volcanoes? Let's face it, as stars go, our Sun is actually, well, pretty boring. Come on, there's nothing unusual about it. There are millions of similar yellow dwarfs in the universe. And yet, we love it. After all, it's the only star we have, and it gives us life. However, it wasn't always like that. Once upon a time, the Sun had a twin, possibly an evil one. What happened to it? Well, let's find out. Now this here is a giant molecular cloud. They're also sometimes called dark nebula. Here, there are many interstellar clumps full of gas, dust, and piles of stars. These clouds have no clear boundaries and often take weird, crazy forms. You can even see some of them with the naked eye. Look at the clear sky at night. They look like dark spots all across the bright Milky Way. And this is exactly where our Sun was born about 4.5 billion years ago. The Sun originated from one of these molecular clouds. Billions of years ago, waves of energy were passing by here. They collected all this material and compressed these clumps into dense nuclei. That's when a protostar was born. This young protostar was a ball of lukewarm hydrogen and helium, and then, millions of years later, the temperature and pressure inside the balls increased. As a result, a star was born, the Sun. But not everything in this molecular cloud has turned into the Sun. The remaining materials began to revolve around the new star, and as you might have guessed, they gradually turned into planets, including our Earth. This is how our solar system was created. But it's quite possible that this is not the whole story, and that at the same time, along with our star, another one was born. The lost twin of the Sun, made from the same materials under the same conditions. But why do we think that it exists? Well, recently, scientists have launched some statistical models to find out more about the birth of stars. And these models have shown that many stars appear not individually, but in clusters, or at least with one sibling. After more research, scientists confirmed that, yep, most stars formed inside molecular clouds are born with a companion. Sometimes these companions stay together. For example, a small star will revolve around a large one. They can even form double, triple, and other star systems. And sometimes their paths may diverge forever. This probably happened to our Sun as well. It could have had a sibling too. Perhaps not even one, but a whole cluster of little brothers and sisters. And one bigger twin with a similar mass and other characteristics. But if that's the case, then where are you, our lost twin? Well, we have one hypothesis, and according to it, this twin may not be as good as it seems. In the 1980s, scientists began to notice a certain pattern in the Earth's history. Approximately every 27 million years, give or take, large-scale extinctions occurred on our planet. Pretty strange, right? Every 27 million years in the history of Earth, some kind of catastrophe occurred that changed its biosphere forever, as if something, as scheduled, cyclically, caused them. Then an astronomer, Richard Muller, suggested that there may be something that caused the events, a certain celestial body. According to him, it could be a dwarf star that we can't see because of how dim it is. It could be located about 1.5 light years away from us. This star rotates around the Sun in a huge orbit, and it approximately takes a whopping 27 million years for it to finish its orbit. And when it gets closest to the Sun, it starts to cause complete chaos. While approaching us, this troublemaker changes the trajectories of comets in the Oort cloud or the Kuiper belt. As a result, all these comets start to rush straight toward us. Then they crash into the Earth and cause mass extinctions, just like it was with dinosaurs. This hypothetical star was named Nemesis. It's the name of the ancient Greek deity of retribution. What is it taking revenge on us for? No idea. Perhaps it didn't like the fact that once upon a time, the Sun took away almost all the dust and gas from a molecular cloud. The Sun became a fairly large star, but the twin remained dark and small. Moreover, in the end, it was forced to fly away in the middle of nowhere. Anyone would be annoyed by something like this. Scientists have put forward various hypotheses about what the mysterious Nemesis is. Perhaps it's a brown or red dwarf, the remnants of a star that has completely depleted its fuel. Or maybe it's not a star at all, but a rogue planet more gigantic than Jupiter. Well, whatever it is, its existence isn't particularly pleasant for us. However, all our attempts to find the culprit unfortunately failed. At the moment, we still haven't found any signs of Nemesis. Recent studies have called into question the theory of regular mass extinctions. If you look more into fossil records, you'll notice that these catastrophes occurred rather randomly, rather than on a clear schedule. Now scientists doubt if Nemesis may actually exist. They also say that any star moving in a similar orbit would be very unstable, and it's very unlikely that it could have survived for that long. But despite the lack of clear evidence, Nemesis had become quite famous online. Many articles and news still mention it in different contexts. They like to write off any dramatic events taking place in the world, like asteroid falls, tsunamis, and so on this mysterious star. So now, all this may seem like a typical urban legend. But let's not forget about something important. Even if Nemesis itself doesn't exist, it doesn't mean that the Sun didn't have a twin. First of all, everything we talked about at the beginning is still relevant. Most stars aren't born alone. The probability that our Sun also had a sibling is still very high. Secondly, there may be evidence of the existence of this lost twin, and is probably somewhere in the Oort cloud. This is a huge cloud in the outer limits of our solar system. It consists of a bunch of comets and other cool rocks. Now, scientists believe that this cloud stores various remnants and fragments of everything that remained after the birth of our solar system. It's like a huge museum of our past. So, in this Oort cloud, scientists have noticed something interesting. Basically, this region seems to be too heavy. What the Oort cloud actually looks like doesn't correspond to our current models of the formation of the solar system. It's too heavy because there are some remnants of something in it. So, there used to be something in the solar system that we don't know about yet. But when scientists included a possible second sun in their calculations, it fit just right. Like a missing piece of a puzzle, the lost twin perfectly matches the gap in the weight of the Oort cloud. So yeah, the Sun almost certainly had a twin. But what happened to it? And where is it now? Unfortunately, this star is most likely already very far away. Probably after their birth, the Sun and daughter, Sun 2.0, spent only a couple of million years together, and then they had to separate completely. Now, the second twin may be hundreds of light years away from us. It can be anywhere in the Milky Way. And yeah, theoretically, we could find it, but that would be quite difficult. To do this, we need to find all the stars similar to our Sun, about the same age, all over the Milky Way galaxy. And even if we make a list of these stars, what's next? We have no way of knowing which one was really the twin of the Sun. So, the lost twin will most likely remain lost, and our Sun will remain forever lonely. Ah, what a sad story. But cheer up, for us it's probably the best. If we had two suns, perhaps the solar system would never have become what it is now. Our planet might not exist at all, and that means that there might be no life. So we probably should be grateful for the Sun's sacrifice. On the other hand, our sunsets would look like the ones they have on Tatooine. Cool.
We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet, or ever did. But that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet. They are free for anyone to see. Over time, some odd shapes have appeared here and there in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our moon is closer. Firstly, because it's believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our moon, for comparison, the gravitational force is only about 16 and 6/10% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation, and communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can't physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet, clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they're made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks, like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has 2 of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These 2 space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has a really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades. But it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Barycenters about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the sun, but they aren't dark. They're just not as bright as the surface of the sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the Sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the Sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the Sun associated with sunspots. As the superhot plasma gas on the Sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California, that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
A recent study has involved almost 200 huge stars that are reaching the end of their lives. It has given scientists more precise information about how the sun will one day end. It turns out that the sun will be about 200 to 300 times bigger than it is now by the time its game is over. For starters, let's begin with some basic information about star sizes. Giant ones reach this stage because they've run out of nuclear fuel and are no longer burning hydrogen in their core. Eventually, the core gets hot enough to trigger the next stage of fusion, which is helium burning. All the stars that were surveyed in this new study were either in this hydrogen shell burning or helium core burning phase. Even though giant and supergiant stars only make up less than 5% of all stars, or at least that we know of, they're actually really visible from a distance because they're so bright. In fact, according to scientists, about a third of all the stars you can see outside on a dark, moonless night are giant or supergiant stars. This study will eventually give astronomers really useful info about massive stars. They'll be able to figure out their size and temperature, no matter where they are or their evolutionary stage. This means they can see a star's true color and use that to find out its radius. Pretty cool, right? It does raise the question, what will our sun be like when it gets old and grumpy? To put it simply, it will expand when it starts burning its hydrogen shell, but then shrink a bit during its helium core burning phase. After a few 100 million years, it'll end up as a giant star, about 200 to 300 times its current size. Eventually, the sun will expand so much that it will simply evaporate. So, what will happen after the sun fades away? Scientists actually have some predictions about what will go down, even though we won't be around to see it. They're pretty sure the sun will turn into a planetary nebula. These planetary nebulae are chunks of gas and dust in space that come from a star that is fading away. They got their name because they looked like planets to people using telescopes back in the 18th century, even though we now know they have nothing to do with actual planets. And here's the crazy thing. Astronomers have found out they can use the level of brightness of these planetary nebulae to calculate their distance from us. In 2018, scientists also found out that the sun is the smallest a star can be to still be able to produce a visible nebula. Any smaller, and it would not be visible. Stars that are up to 3 times more massive than the sun will produce brighter nebulae. The sun is currently 4.6 billion years old, but it's estimated to have another 10 billion years until its end. The sun is also getting brighter with each year. It doesn't seem like a lot now, but it's actually going to cause some big problems for Earth. In about 1 billion years, the sun will be too bright for life on Earth to survive. Our oceans will evaporate, and it will be too hot for water to form again. So unless we find a way to escape from this planet, humanity only has about 1 billion years left. Will Earth still be around by the time the sun turns to dust? It's hard to know for sure the exact timeline. But even before that happens, Earth will most likely be scorched and lifeless, with no atmosphere or oceans left. It's not clear how close the sun's outer layers will get to Earth. But if they get too close, it could cause Earth to spiral into the sun and disappear altogether. Even if our planet does somehow manage to survive the sun's giant phase, it will be orbiting a hot white dwarf, or a star that has run out of its fuel. In that distant future, the sun will be barely larger than our planet. Eventually, the sun will cool and dim completely. It'll move to another stage called a black dwarf. It will cause Earth's orbit to loosen up, and our planet will spiral into the fated sun. But interestingly, the sun doesn't get the final say in what happens to Earth. Gravity keeps planets in orbit, but it also attracts them to each other, which can cause their orbits to flex and drift. This could lead to the solar system destabilizing and ejecting planets, including Earth. Basically, a lot might happen in the next 5 billion years before the sun becomes a red giant. There's also another scenario. While most stars stay far away from our solar system, there's a chance that one could come closer in the next billion years. Even a small star or black hole could mess up the orbit of our planet if it gets too close. But don't worry too much, the odds of that happening are low because of the amount of space between stars. Our sun is a solitary star, so there's little to no chance we'll be able to catch a ride with another one nearby. However, many stars in our universe have companions. Among these stars is Castor, a stunning system that comprises 6 stars and is one of the brightest objects in the night sky. Although humans have been admiring Castor for ages, they were not aware of its true nature until the invention of telescopes and spectroscopes. Even with the help of a small telescope, it's evident that Castor is composed of 2 primary stars, Castor A and Ba, that revolve around each other. These stars are larger than the Sun and need 467 years to complete one orbit. In total, Castor is composed of 6 different stars. The biggest one, called Castor AA, is roughly 2 times larger than the Sun, while the smallest has about 0.5 of the Sun's mass. If humans want to survive the next billions of years, we might need to set up camp somewhere else in the universe. It may seem like something out of a sci-fi movie, but it could be our reality one day. Thankfully, NASA is already looking at some options. They've discovered 2 new planets, TOI 700e and TOI 700d. That might be new hotspots for us humans. TOI 700e is the optimistic zone, which means it could have water and even an atmosphere. TOI 700d is in the conservative habitable zone. So, scientists aren't too sure about it yet, but hey, we'll take what we can get. But hold on. Before you start packing your bags, there's a little problem. How do we get there? It took John Glenn months of preparation just to circle Earth 3 times. So we might need to start working on our astronaut training. Well, at least we have some options for our future intergalactic vacation plans. Wouldn't it be nice if we could time travel so we could see what our solar system will look like in billions of years? An American physicist named Ron Mallett has proposed one interesting theory for time travel. It uses light, a resource that is abundant in the universe. His idea involves using a rotating cylinder of light, which could transport an object in both space and time, similar to how a bubble moves in a swirling liquid. Mallett suggests that a cylinder of the right shape could allow for travel to the past and the future. To test his theory, he has been trying to secure funding for an experiment. However, some scientists consider Mallett's theory to be impossible and unnecessary to test. We might also be able to travel through time if we move fast enough. According to Einstein, the way we experience time can change depending on how fast we're moving. If we go really fast, time slows down. For example, astronauts in space age a tiny bit more slowly than people on Earth. This is important for things like GPS, which would be incorrect without special adjustments because of how time is affected.
What if the sun went boom? Well, you can guess it would be super bad news for us. This was sure a short video, huh? Nah, wait, I have more. If the sun blew up, chaos would ensue in our solar system. But scientists tell us that it will certainly happen one day. But why? How exactly would events unfold? And is it possible for us to somehow survive this event? Hey, let's delve into it. First of all, get ready for a journey to the sun's core. The sun's heart is packed with hydrogen atoms, having an out-of-this-world dance party. These atoms are so excited that they smash into each other with all their might. And when they collide, something magical happens. It's called nuclear fusion. And in this fusion fiesta, the hydrogen atoms combine to form helium atoms, a chemistry experiment on a grand scale. During this nuclear fusion, a teeny bit of mass from the hydrogen atoms is transformed into a massive amount of energy. It's Einstein's famous equation E equals mc squared coming into play. Energy is unleashed in the form of light and heat, radiating outwards to brighten up the entire solar system. And once all these processes get going, a bunch of energized particles called photons join the fun. These photons are like tiny packets of light, bouncing and zipping around in all directions. They play a crucial role in carrying the sun's energy through space, illuminating our world and warming our cozy planet. But to keep all this going, so that atoms don't escape and create complete chaos, the sun's core needs to be under tremendous pressure. This pressure comes from the immense weight of the sun's outer layers pressing down on the core. The outer layers are squeezing the inner core. But the inner layers don't give up. The energy created from fusion and the bustling photon party tries really hard to escape the sun's core. But the core is so dense, like me, and the pressure is so big that the energy takes its sweet time to make its way out. It bounces around, gets absorbed, and re-emitted by other particles. Eventually, after a long time, it reaches the sun's surface and zooms off into space, reaching us as sunlight. So now you know how the sun works. Now, what happens once it reaches the end of its life? Well, here's the twist. Our sun has a limited supply of hydrogen fuel. In about 5 billion years, it'll run out of its fuel. After that, the star will undergo some big changes. Now, pay attention, because there's a pretty good chance we're all going to miss this. First, the sun will puff up and become a red giant, exploding like a balloon. It will grow so big that it will swallow up the inner planets, including our beloved Earth. Talk about a sun taking up all the space. So we won't even see the end of our sun unless we move somewhere further away. After the red giant phase, the sun will shrink a bit. Its outer layers will fade away into space, leaving behind a beautiful planetary nebula. It'll be revealing its glowing core. Ooh! The core, now filled with helium,
Will start sounding weird.
and will start fusing heavier elements like oxygen and carbon. These reactions won't be as energetic, like a party with less dancing and more chill vibes. Eventually, even the helium will be used up, and the sun will become a compact white dwarf, a stellar retiree enjoying its retirement home. Scientists estimate that the sun has about 7 to 8 billion years left before it dims its lights. Don't worry though, by that time, humanity might have traveled to far-off galaxies, or maybe even evolved into amazing space beings. So our sun won't go out with a bang like fireworks. It's not big enough to become a supernova or a black hole. Those stellar superstars need way more mass than our sun to pull off those cosmic tricks. But what if it blew up very suddenly, just like an abrupt event without any reason? Well, let's see. Imagine this. The sun goes boom, and Earth is in for a wild ride. The event unleashes an insane amount of energy, sending a shockwave racing through space at the speed of light. It takes about 8 minutes for this shockwave to reach Earth. Why? Well, the sun is a whopping 93 million miles away from us on average. So it takes a little over 8 minutes and 20 seconds for the sun's light to travel all that distance and reach us. But let's talk about the event itself. It would be a great sight to witness, but sadly, it would also be the end. Roll credits. The crazy amounts of unleashed energy would cause the sun to expand rapidly, again swallowing up the inner planets, including our Earth. And that's not all. Brace yourself for a massive burst of radiation. The sun would unleash a torrent of supercharged particles. We're talking about X-rays and gamma rays, the kind that can seriously mess things up. When these high-energy particles hit the atmosphere, they go wild, causing all sorts of chaos. They ionize the atmosphere, creating a ginormous electromagnetic pulse. This pulse is like a shockwave for electronic devices. It fries them, zaps them, and leaves them useless. So if your gadgets aren't protected, they're in for a rough time. Speaking of rough times, after that, it's instant vaporization for our planet. But the sun's grand finale just doesn't mess with Earth. It wreaks havoc on the entire solar system. That massive burst of energy would be crashing into everything in its path. Planets and other objects get knocked off of their cozy orbits, causing chaos and unpredictability. The asteroid belt between Mars and Jupiter, kapow! It's gone, obliterated, or scattered to the cosmic winds. And even planets that will survive this event will probably go off their orbits to wander somewhere. And let's not forget about the outer planets, like Jupiter and Saturn. These giants generate their own internal heat, which keeps them cozy and attracts lots of moons. But the sun's boom would steal their warmth, turning them into incredibly cold places. And now that we've discussed how catastrophic all this would be for everything in our solar system, let's ask the logical question: can humanity make it? The short answer is nope, we wouldn't make it. Everything would be wiped out, except maybe some sneaky bacteria hiding in the shadows. But in a crazy scenario where the sun gave us a heads up about its plans, we might have a fighting chance. If we knew in advance and had time to prepare, we could get our survival gears turning. So what could we do? Since Earth itself won't survive the sun's tantrum, we'd have to move somewhere. Remember how we mentioned that not all planets would be completely destroyed? Well, sadly, the ones closest to the sun, Mercury, Venus, and Earth, would disappear. So the easiest option would be to move to some other solar system with its own Earth-like planet. But what if the Earth somehow managed to survive this catastrophe? Let's not think about how it happened and just discuss the consequences. Well, our climate would go crazy. During the first moments of the sun's kaboom, the radiation and particles would crank up the temperature big time, like a never-ending heat wave. We're talking major greenhouse effect. The oceans would evaporate, creating thick, fluffy clouds that trap heat and refuse to let it escape into space. And after that, without the sun's warm embrace, the Earth would quickly become an icy freezer. So we'd have to think outside the box. One idea would be to take shelter deep underground, where we won't be that much affected by radiation and sudden temperature changes. As you dig deeper, the temperature rises. So, with the right tools and resources, humanity could hunker down in fortified bunkers, surviving for a couple of years without the sun's rays. Why just a couple of years? Well, remember how we said the sun is a gravity center of our solar system? Without it, Earth would be adrift in search of a new center of gravity. Imagine our planet, our trusty satellite, the Moon, and all the other planets slowly floating away into space. Luckily, our trusty sun is hanging in there, keeping us warm and shining for many more cosmic adventures to come. So, we're safe for a few billion years. But it's always fun to imagine impossible scenarios. So stay tuned for more what-ifs.
What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. Astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance. But even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system: Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago, but recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that 2 gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the Sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the Sun, but they aren't dark. They're just not as bright as the surface of the Sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the Sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the Sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the Sun associated with sunspots. As the superhot plasma gas on the Sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe, one in India, Australia, one in the Canary Islands, one in Chile, and one in California, that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
Of fire and smoke fly upward, and the rocket launches. The Delta IV Heavy is one of the most powerful rockets people have ever made. 3 massive engines burn tons of fuel, helping the spacecraft gain altitude. The 2 side boosters undock, leaving the common booster core for further ascent. When in orbit, the rocket releases its payload. This is the Parker Solar Probe, the first spacecraft to touch the Sun, and we'll follow its journey step by step. The probe was launched on August 12, 2018, and began its journey toward our star. The Sun is 93 million miles away from Earth. That's 390 times the Earth-Moon distance and 36,000 times the width of the United States from coast to coast. The particles of light that the Sun emits need 8 minutes to travel this distance. For our conventional rockets, that journey would take more than 200 days. But the Parker Solar Probe covered it faster, using gravitational maneuvers. On its way from the Earth to the Sun, the probe circled around our neighbor, Venus. All it had to do was enter the planet's gravitational field and let it attract itself. At this point, our space probe got an extra boost, and it didn't need to waste any fuel. After making one orbit, the space probe's engines changed the trajectory, and the probe left the orbit of Venus. It got enough acceleration to travel to the Sun. And on November 5, 2018, the Parker Solar Probe made its first approach to the Sun. Before touching its surface, the spacecraft had to enter the star's orbit first. To achieve this, it did even more gravitational maneuvers. Only after that did it start circling the Sun, the heaviest object in the solar system with the most powerful gravity. So, it'll give the probe an incredible amount of acceleration with each flyby. The Parker Solar Probe was constantly moving between 2 points. Those were the perihelion and aphelion. Look, here's the Sun, and here's the probe's orbit in the shape of an ellipse. The closest point to the Sun is the perihelion. The Sun was pulling the probe there at an incredible speed. At this point, the probe began to move away from the star. It still had a lot of speed and energy, but it was struggling against the gravitational force of the star, so it gradually slowed down. The point where the probe lost all its acceleration is called aphelion. The star's gravitational force won, and the probe began to move back toward the Sun, picking up speed again. The probe made several circles following a stable orbit, but then its orbit intersected with that of Venus again. Another gravitational maneuver, and after that, the Parker Solar Probe's trajectory shifted slightly, and it gained more speed. The perihelion point of its orbit was now closer to the Sun. The probe made several more circles following this new orbit. Then again, it neared Venus. Another approach to the Sun. Each encounter with Venus corrected the probe's trajectory and gradually reduced its distance from our star. In April 2021, the Parker Solar Probe finally came so close to the Sun that it touched its corona. Although the actual distance between the probe and the Sun was 5.3 million miles, that still counted as a touch. Let's look at the structure of our star by cutting it in half. This is the core of the Sun. It's about a quarter of its width. The core is 150 times as dense as water. Because of the intense pressure and high temperature, nuclear reactions occur there. hydrogen gets converted into helium, giving off an incredible amount of heat and radiation. The next layer is the radiation zone. This is where the heat is transferred from the core to the next layers. But the photons here don't move in an outward direction. They can be directed anywhere and re-radiated many times. Scientists believe that the average time it takes a photon of light to travel from the core to the next layer of the sun is about 10,000 to 170,000 years. Then there's the convection zone. This is what's considered to be the surface of the sun. But it's not a solid surface. It's an ocean of hot plasma. It looks like a bee honeycomb. That's because the heated plasma rises from the lower layers, creating something like mini geysers. And while it's still hot in the middle of those geysers, their edges cool down, creating an amazing pattern on the sun's surface. The next layers are the sun's atmosphere. First, the photosphere. This is the layer that gives off light. And that's exactly what you see when you look at the sun. But careful, don't do that. You need special equipment to look at our star. The photosphere is up to 250 miles thick. This is about the height at which the International Space Station moves above Earth. Then, the chromosphere, or the sphere of color. This layer of the sun's atmosphere gives the star its reddish hue. Solar prominences appear here. Those are powerful emissions of matter leaving the surface of the sun. Their speed can reach 430 miles per second. At some point, they get caught by the star's magnetic field and pulled back. And then there's the corona, a gaseous envelope of the sun. The most powerful ejections take place there. You can see the corona during eclipses, when the moon covers the solar disk. Then you can notice some kind of glow around the star. This is the corona. It extends for millions of miles around the sun. And the Parker Solar Probe touched precisely that area. That's where solar material and radiation are still tied to the star's gravity and don't fly off into space. And all that is beyond that area is the solar wind. It's the material and radiation that managed to escape the sun's gravity and set off into space. The Parker Solar Probe surprised astronomers by providing more information about this boundary. It turns out it's not a perfect circular wall like we used to think. The boundary is broken and uneven. It looks more like a mountain range. These bumpy regions have such a shape because of the uneven flow of plasma from the surface of the sun. The larger and more powerful the flow, the farther the boundary is from the star's surface. But scientists don't know yet what exactly causes this difference. After making the flyby around the sun, the Parker Solar Probe continued its journey and started to move away from the star again. Researchers are expecting another 4 approaches in 2022. In August 2023, the probe will make a flyby around Venus. It'll gain more speed and approach the sun at a record close distance. The next Venus flyby will happen in 2024. And hopefully, the Parker Solar Probe will be able to withstand the high temperatures and radiation so close to the sun. Luckily, scientists have taken care of that. The probe has a solar shield. It's attached to the side of the probe that will face the star. It's about the size of a house window and about 4.5 inches thick. It's made of a special material that can withstand a temperature of about 2,500 degrees Fahrenheit. That's almost 6 times higher than the temperature of a regular kitchen oven. The body of the probe is made of a white material that reflects sunlight. All the scientific equipment is placed right in the center of the shadow of this shield. If the sun's rays hit the unprotected body of the probe at close range, all the equipment will be out of action in just a few tenths of a second. The Parker Solar Probe is equipped with the Electromagnetic Fields Investigation Instrument. This is a system for measuring electric and magnetic fields, radio waves, temperature, and plasma density. The Wide Field Imager for the Parker Solar Probe, or WISPER, is an optical telescope, the one that took those stunning images of the moving plasma in the sun's corona. These streamers are what you see during solar eclipses. The Solar Wind Electrons, Alphas, and Protons investigation measures protons, electrons, and helium ions. It helps scientists study solar winds. It often harms our technology. Unexpected flares on the surface of the sun can cause severe solar winds. They can burn chips and satellites orbiting Earth. Given that we have the ISS, where people work all the time, we need to know more about solar winds and how to protect ourselves from them. While the Parker Solar Probe continues its research, it's already set several world records. It's the closest to the sun human-made object. It's also the speed record holder. During its final approach to the Sun, the probe reached a speed of 101 miles per second. That means it could cover the distance from New York to Los Angeles in just 24 seconds. And a trip around Earth would take about 4 minutes. A journey to the Moon in such a spacecraft would only take 40 minutes. In 2025, the Parker Solar Probe will make its closest approach to the Sun, reaching a speed of about 430,000 miles per hour. But even this speed is only 0.064% of the speed of light.
You may think the Earth is pretty big, but the Sun makes up almost 99.9% of the mass of the whole solar system. The rest of the mass is made up by the planets and their satellites, asteroids, comets, gas, and dust. It's around 93 million miles away from our planet, but it keeps us warm every day. Its temperature is about 10,000 degrees Fahrenheit, but the space surrounding it is still cold as ice. To understand this, we need to distinguish between heat and temperature. Heat is the energy inside some object. Temperature is something that tells us if that object is hot or cold. When the heat is transferred to that object, it makes its temperature go up. When the object is losing heat, the temperature goes down. Heat can be transferred in 3 different ways. The Sun does it through radiation. That means it's releasing heat in the form of light. Your body radiates heat too, as infrared waves. That's why thermal imaging cameras will detect that you're in the room even at night. The hotter the object, the more heat it will radiate. The temperature only affects matter. Since space is mostly a vacuum, it doesn't have enough particles for heat to transfer in any other way than through radiation. When the heat from the Sun gets to an object, the atoms start absorbing energy, but the heat can't transfer since there's no matter in space. Those rare atoms and molecules in space will absorb the heat. And they'll simply stay that way, while the cold vacuum will stay cold. There's a lot of matter inside Earth's atmosphere, so the energy of the Sun can transfer easily. But if you put an object outside of the Earth's atmosphere in direct sunlight, it would end up heated to 250 degrees Fahrenheit because it's matter made of atoms and molecules. The temperature of the vacuum is negative 454 degrees Fahrenheit. That means, depending on where you are, space can either burn or freeze you. The Sun isn't actually yellow. It emits light over a wide range of wavelengths. We can tell both its temperature and color by the peak in its spectrum. For instance, cooler stars will appear red, and hotter stars will be blue with yellow, orange, and white stars in between. When it comes to the Sun, the spectrum peaks at a wavelength we'd usually call green, but our eye perceives it differently. So, the shade of green in combination with other wavelengths from the spectrum is going to look white to the human eye. We generally see the Sun as yellow because our atmosphere scatters blue light more efficiently than the red one. During sunrise and sunset, there's more red light in the spectrum of the Sun, which gives us amazing sceneries. Sunspots are part of the Sun's visible surface that are on average way cooler than the Sun itself. They overlap with parts that have an increased magnetic field. These parts don't allow the release of heat to the Sun's visible surface. That way, the rest of the Sun's surface is 3 times brighter than those sunspots. That contrast makes them appear almost black. If we could take a sunspot apart from the Sun and place it somewhere in the night sky, it would be different, as bright as the Moon when we see it from the Earth. All the planets in our solar system spin in the same direction because they were formed from one protoplanetary cloud, except for Uranus and Venus. They have probably had some strong impact on them that made them spin in the opposite direction. But it's different with galaxies. They don't usually form the same cloud of dust and particles. Also, they're not randomly distributed across space. They come in filaments, dense, slender strands of dark matter and galaxies, with voids in between. Proto-galaxies are linked by gravitational forces in small areas of space. This is probably because of the distribution of dark matter throughout the universe. The matter in the filaments moves in a corkscrew motion and goes towards the densest area. So, there might be a common direction galaxies tend to spin, but it's mostly random. There's a possibility we'll see a lunar elevator one day. Yep, a cable anchored to the surface of the Moon. it would stretch 250,000 miles. We wouldn't be able to directly attach it to our planet because both Earth and the Moon are moving. But we could keep it terminated high in our planet's orbit. Some researchers believe we could build such an elevator for a few $billion. The Moon has resources we could definitely use. A rare form of helium found there could be of use in fusion power stations on our planet. Also, we could take some other rare elements and use them in smartphones and the rest of electronics. So, after around 53 trips up and down, the elevator could pay for itself. The cable would be as thick as a pencil, but its weight would be around 40 tons. It could even be made of materials we already have here on Earth, with no need to invent something. There could even be a combination of two elevators. A spacecraft would winch up an elevator from the surface of our planet to a space station. Then it would be flung towards the Moon. There would be another elevator to finally lower it down to the surface of the Moon. Planets in our solar system have predictable and stable orbits, but gas-giant collisions could have happened at an early stage when a planetary system was still forming. In case of a head-on collision, two gas giants would merge. They wouldn't end up losing their mass, the materials in their gaseous envelopes, or the ones in their solid cores. Such a collision at a higher speed would cause the loss of the major part of the envelope gas, and very high speeds, boom, both planets are gone. It's different if it's not a head-on collision. If two cores manage to completely avoid each other, gas giants won't merge, but they'll lose some of the mass. Gas giants might even change their shape due to such collisions. Astronomers found out there's a galaxy extremely far away from us that looks similar to our Milky Way. We now see it as it was when the universe was only 1.4 billion years old, and now it's 13.8 billion years old. It took over 12 billion years for the light to come from this faraway galaxy and reach our planet. This galaxy is peaceful, stable, and surprisingly non-chaotic, unlike all other galaxies that were quite turbulent in their early stages. To leave the Milky Way, we'd have to travel around 25,000 light-years away from the center of the galaxy, or 500 light-years vertically. Our galaxy is a disk of stars that spreads around 100,000 light-years across and is 1,000 light-years thick. The Sun, its central star, is located halfway from the center of the galaxy and close to the middle of the disk in the vertical direction. We'd have to go further than its edge to get away from the halo that surrounds the Milky Way, old stars, diffuse gas, and globular clusters. If you wanted to go even further to see the Milky Way in all its glory, you'd have to travel 48,000 light-years vertically. At this moment, we don't even have a telescope we can send there. There are central stars that eat planets. Our solar system is stable, unlike many other planetary systems, so we don't have to be afraid the Earth or some other planet will change its orbit and go towards the Sun. But at least a quarter of other planetary systems with orbiting stars similar to the Sun have a pretty chaotic past. In some of them, there are planets that used to move around, and their unpredictable migrations have disrupted the paths of some other planets, or even pushed them outside of their orbit. That means some planets probably have fallen into the central star. When that happens, the planet gets dissolved in the outer layer of the star, which means it gets eaten.
Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If the star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? Yep, it's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moon quakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the Sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails, myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments.
We've sent more spacecraft to study the local environment on Mars than on any other planet. We have no evidence that life exists on the red planet or ever did. But that didn't stop some people from wondering. Mostly because of the pictures that NASA's Perseverance and Curiosity rovers take regularly of Mars' surface. Feel free to check them out for yourself on the internet. They are free for anyone to see. Over time, some odd shapes have appeared here, and they're in these pictures, making some people believe there is some sort of creatures living there already. Back in 2008, one of the rovers took a picture of a rock that looked very much like a female figure. Other photos seem to show animal-shaped figures, utensils, or other Earth-like objects. Again, there is little to no proof of this theory, as rocks can be of all sorts of shapes and sizes. But if you look at the pictures, it does make you wonder. A lot of people in the scientific community do see Mars as a better place for long-term settlements, even though our Moon is closer. Firstly, because it believed there is indeed water on Mars. It's just stuck in underground frozen lakes. The soil doesn't seem to be rich in nutrients, and it may have some harmful chemicals. Moreover, on the red planet, the gravitational pull is only 38% of Earth's, so it's easy to carry heavy objects here. On our Moon, for comparison, the gravitational force is only about 16 and 1/16% of that found on Earth. We already have people studying how we might live on Mars right here on our planet. It's because certain regions of Earth closely mimic the harsher conditions on Mars. Devon Island, for example, is the biggest uninhabited island on our planet, located in the Canadian Arctic archipelago. It's easy to see why it's hard to live here. The soil stays frozen all year. The eastern part of the island is covered by a thick ice cap all year round. Summers here only last for less than 50 days and aren't really that warm. Not a lot of plants can grow here, so no animals can adapt to thrive and multiply. As such, the Hutton Mars project started here in 1997 to offer astronauts unique studying opportunities. There are few options here in terms of logistics and transportation. And communicating with people living outside the island is also a bit more difficult. All because of the temperature and barren soil. Think about it, if we can find solution to live here, we might be able to do it on Mars too. Regardless of our local training, the conditions on Mars are currently inhospitable. That's because it's really cold. On average, the temperature is about -81 Fahrenheit. Even during the summertime, it's never hotter than 86 Fahrenheit. And to top it all off, the planet's atmosphere is made of 95 3/10% carbon dioxide, so there's literally no way we could breathe there without special devices. Mars also lacks a magnetic field on its surface, so it is attacked by the sun's radiation. Because of the temperature variations, Mars often experiences powerful dust storms, which can surround the entire planet. Technically, these storms can't physically harm us, but the dust might clog electronics and render solar-powered instruments unstable. We know now that life as we know it is impossible on Mars, but did it ever exist there? This is a question long debated by scientists, since NASA's investigations have determined that some parts of Mars were habitable at one point. We don't know for how long or how far back, and just because something could have lived there, it doesn't mean it actually did. Other recent photos from Mars showed a cloudy sunset. Does that mean it also rains on the red planet? Well, not really. For starters, on our planet, clouds are water vapors, and once it starts to rain, the water reaches the surface of our planet in liquid form. This process isn't the same on Mars. Surprisingly, there is more water in Mars clouds, but they're made of iced water. Think of them as a tiny icy fog. Combined with the thin atmosphere and cold temperatures, it keeps the clouds from ever falling to the surface. Sunsets are different here too. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars, so the sunsets here have more of a bluish tint. Similar to Earth, Mars is also tilted on its axis, which means it also has seasons. Because the southern hemisphere is directed away from the sun when Mars is farthest from it, the winters here are far colder and summers way hotter. Calendars work differently on Mars too. A year here lasts for about 1 1/8800th Earth years. A day is a bit more longer than 24 hours. Even if we were to ever move to Mars, we'd still have to communicate with our Earth. It would be a bit difficult to do, since a message sent back home would take about 15 minutes to reach its destination. It's not that bad given the entire distance, but it would make video calls kind of annoying. As difficult as it might be for now to live there is a lot of stuff to see. Some scientists believe that if we were completely colonize Mars, a list of locations would soon be declared national parks, like the area surrounding Olympus Mons, which is the biggest known volcano in the solar system, stretching over 16 miles. Valles Marineris would be another cool location. It's been a huge complex of valleys about the distance from Los Angeles to New York. Mars also has some cool polar ice caps, which sometimes experience dry ice snowfall. Saturn and Uranus are unique planets in our solar system because of their rings. It may not have one now, but Mars may be getting a ring of its own in the future. Don't get too excited. It's estimated it might take 10 of millions of years. Mars' largest moon, named Phobos, will be torn apart at one point. The debris resulting from it will settle in a rocky ring around Mars, resembling that of Saturn and Uranus. Speaking of moons, Mars has 2 of them that we know of. Apart from Phobos, there is also one more object called Deimos. Both were discovered by an American astronomer named Joseph Hall back in 1877. The scientist had almost given up his pursuit to find Mars moons, but thankfully he was urged to continue the project. The next night he stumbled upon Deimos. 6 days after that initial finding, Hall found Phobos. These 2 space objects may be in fact some asteroids captured by Mars gravity. Another theory suggests they formed in orbit around Mars at about the same time the planet came to be. The fact that Mars has a really weak gravity may also be the reason for this fascinating event. Mars was hit by large asteroids many years ago, just like our planet was. A lot of that debris surely went back to the surface, but some of it was ejected back into space, as Mars' gravity wasn't strong enough to pull them back. They had quite a journey, some of them even ended up on Earth. These pieces of Mars also helped us understand the planet's unique features. We've continued to send robots to the Red Planet quite successfully in the past few decades, but it still remains quite difficult to imagine people will soon land on Mars. Even considering the current rocket technology, the journey would take us 6 months. And that's an optimistic scenario, given everything goes well on board. After landing, humans will be exposed to deep space radiation and microgravity. Both of these have serious effects on the human body, which we've yet to figure out how to counteract. That's why research is continuously performed on the International Space Station regarding the long-term effects of microgravity.
More than 1 million Earths can fit in our Sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the Sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the Sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us.
So there you are. You've been driving for hours through the night. You didn't have any chance to sleep, so your mind is hanging by a thread. You stop the car and go out to stretch your limbs. And then you look up into the sky and see a beautiful sunrise. Whoa, wait! There are 3 suns in the sky. You rub your eyes, but nope. there are still 3 bright stars in the sky. No, our home star hasn't been torn into 3 pieces, nor has it been visited by 2 other stars. This is called a sundog. It occurs mostly during severe frosts. Small ice crystals in the sky bend the light. As a result, you may see 3 bright spots in the sky instead of just 1. This phenomenon is officially called a halo. Usually it's just a circle around the sun. You can even see a halo at night, too. Just look at a street lamp and you'll see a bright circle around it. Sometimes a halo can take on a fancier shape. If there's a lot of ice in the air, the light is warped even more, just like in a room with a dozen mirrors. Then the halo can take on the shape of a human eye. Because of this phenomenon, a false dawn can occur also. While you're looking at the horizon, the dawn begins and the edge of the sun appears. A little bit more and wait! The sun starts to just dissolve in the sky. After a few moments, it's dark again. And only a minute later, the real sun shows its face. It was the same light curvature effect you saw before with the 3 suns. Only now, the light is curved vertically, not horizontally. And instead of the real sun, its reflection in ice crystals in the sky appeared. But the sun with 3 stars on the horizon is actually real. Not on Earth though, but 340 light-years away. There's a star system at the center of which lurks a star almost twice the size of our sun. And there are 2 small stars orbiting around this giant. From afar, they look like dumbbells. This strange world has a planet too. Sunsets and dawns there really happen with 3 stars. If you brought your significant other to a park bench to watch a sunset here, your date would go just fine. Whatever that means. Now you're at home, watching YouTube to the sound of a thunderstorm. Suddenly, you hear the sound of a window shattering and all the lights in the house go out. You see a streak of bright blue light from under the door to the next room. You open the door and see a sphere of lightning the size of a basketball. It's hanging still, occasionally zipping tiny lightning bolts to its sides. After a couple of moments, the ball flies away toward the window through which it got here. You've just witnessed a ball lightning. Clever name. Such a phenomenon has been observed in different parts of the world, and each time it scared people to bits. In 1753, an experienced sailor went up on the deck of a ship. He looked out and saw a big blue ball of fire over the water. The sailors wanted to turn around and catch up with this mystical orb, but it was moving too fast, and before they could change course, the ball flew upward at a tremendous speed. Then there was a powerful explosion, the force of 1,000 cannons. The boom toward the top of the ship's mast, and several sailors were thrown back by the shockwave. In the same instant, the orb disappeared, leaving behind only the unusual smell of sulfur. And one recent case occurred in Eastern Europe. During a thunderstorm, a ball of lightning flew into a woman's house. The woman remained motionless, and the blue ball flew right over her head. The lightning then discharged into the electrical wiring inside the wall and disappeared. But despite eyewitness claims, ball lightning still remains an unconfirmed phenomenon, and even if it exists in reality, we can't explain how it appears. Some scientists have even been able to create ball lightning in the lab, but those spheres weren't stable and they weren't anything like what the witnesses described. Moving on. This cloud looks like a dinosaur. And this one looks like a cat. And this one, it looks like these clouds are falling down. That's just a mammatus cloud. Their shape really makes them look like chunks of clouds about to slam on the ground. Well, that's not going to happen, but you better start seeking cover anyway. Such clouds are a sign of a severe thunderstorm coming. It takes a lot of moist air with ice crystals at the top and dry air at the bottom to create such clouds. Then vertical currents of air appear between these layers, and these currents make the clouds take the shape of a human brain. And this giant cloud looks like a dome that's going to cover an entire city. In fact, that's exactly what happens. A huge cloud covers a large area and then rains heavily on it. Sometimes the front of such a cloud takes a bizarre shape, like in these pictures. It looks more like several giant spaghetti clouds, or even giant cloud worms. This phenomenon can often be seen in Australia, and it's called a morning glory. It happens because a strong wind twists parts of the cloud on both sides, and then the huge sheet of air dough splits into thick strips. And sometimes you can see clouds in the sky made of birds. Wow, that cloud moves quickly and changes shape. It becomes more transparent and then denser and darker again. The birds seem to be involved in some kind of dance or performance. But they're not doing it for beauty or for the crowds of spectators gathered below. They're doing it for protection. When birds group themselves into such a cloud, they intimidate birds of prey. An eagle or hawk would have a hard time picking out a single target among the endless numbers of birds. And they move quickly, covering each other. Fish are huddled together in schools in the same way. Such a cloud might just spook a hungry predator. For another unusual phenomenon, we'll have to look at the Earth from a bird's eye view, at night. We head to the Middle East. There's a large desert there and it's completely dark, except for one spot. It's a big circle that glows with a bright orange light, the Darvaza Crater. And it's just a giant gas burner. Years ago, geologists found gas there, and they started mining for it. But when they excavated, they came across a void underground. The void collapsed and it formed a crater. It's as wide as half a soccer field and as deep as a 5-story building. Gas began to come out of the cracks in the crater, and since animals were often grazing near this place, the gas could harm them. Then the geologists decided to set these gas streams on fire to exhaust the source. One spark, and the crater was filled with columns of fire 30 feet high. Geologists thought the fire would be over in a day or two. But if you come here now, you'll see this gateway to the underworld is still burning, and it's been going on for almost 50 years. In 2013, a man descended to the bottom of the burning crater for the first time. He collected many different samples there, and scientists were able to find bacteria that aren't found anywhere else on Earth. They're quite comfortable at the bottom of this endless burning fry pan. Another mystical phenomenon can be seen in the desert: a sand waterfall. When the wind brings a lot of sand to the edge of the canyon, it begins to fall down. Now amplify this effect 100 times, and you get a sand waterfall in Saudi Arabia. It really is like Niagara Falls, only there's not a drop of water. The locals say this phenomenon warns of an impending sandstorm. And the last phenomenon can only be seen in winter. You see a frozen river, and there's some strange stones sticking out of the ice. But when you get closer, you can get scared, because it's not a stone, but a crocodile snout. Don't fret though, it can't jump out from under the ice and take a bite out of you, and the animal isn't in trouble as you might think. Crocodiles can't breathe underwater, and they need to constantly rise to the surface to take a breath. But when the water freezes, that becomes impossible. So crocodiles stick their noses out before severe frosts and leave half their body on the surface. They can breathe safely. Plus, the ice and cold air cools the crocodiles and slows down their metabolism. So that's how crocs can survive the cold and hungry times. And so, this true story about crocs is not a croc. Get equipped for any season with brand new Brightside merch. Click the link and grab your print. 2 bright beams of sunlight are traveling across your forehead, cheeks, eyes. Ooh! You scrunch up your face and sneeze loudly. It would be nothing unusual if the sun's rays weren't coming from 2 different stars. Yup, you're still on Earth, but this Earth has 2 suns. What would your life look like in such a world? It depends on the star's mass and their positions relative to Earth and each other. If the stars were small, their gravity wouldn't be enough to keep our planet in its orbit. It'd eventually drift away into space. But if one of the stars was larger than the other, it would have a much stronger gravitational pull, and sooner or later, Earth would end up too close to it. It'd become too hot to live on the planet. You know, boiling oceans, evaporating rivers and glaciers, and scorching hot air. Lovely. In the end, our once blue world would crash into the star and, disappear. The only chance for Earth to have a stable orbit would be to move around only one of the 2 suns. But it wouldn't be that great for all kinds of life forms on the planet. Every once in a while, the two stars would face both sides of Earth. It would mean there would be no nights. Our planet would get twice as much heat as usual. It'd also be bombarded with double doses of radiation. And of course, solar winds would become twice stronger. During such periods, you'd have to hide indoors and probably order drone delivery. Because you set your foot outside, the two suns would get you toasted in no time, what with all that heat and solar radiation. Uh-oh, it doesn't sound optimistic. Maybe it would be better if our planet was moving around both stars. Perhaps. Its orbit would be rather unstable in this case, and still, it would be better than experiencing crazy heat waves every now and then. But in this situation, the stars would have to be close to each other, and Earth would most likely travel too far away to get enough heat to keep its water liquid. If our planet had been developing in such conditions from the very beginning, now it would be just a frozen rock with no life on it. How about the most optimistic scenario? Our planet would get itself two similar-sized stars, and each of them would be more than half as powerful and bright as our current sun. By the way, it sounds rather realistic. Such equal-mass double stars do exist. Their common gravitational pull would be just enough for Earth to not fly out into space, and the amount of energy our planet would get would be more or less the same as it receives now. But the combined mass of the stars would be about 1.5 times the mass of our current sun. It would mean their gravity would also be stronger, and 1 year on the planet would be shorter. It'd last not 365, but around 280 days. But Earth would only feel comfortable if it was at least 4 times farther from its stars than they were from each other. Then our planet would happily move around their common center of mass. In other words, the suns would have to be less than 10 million miles apart. Then the rest of the planets in the solar system, including Mercury, would have stable orbits. If you lived on the Earth that was moving around two stars, you'd be able to watch awesome solar eclipses. But it would not be the moon blocking the sun, but one of the stars preventing you from seeing the other. Instead of several minutes, eclipses would last for hours on end. They would also occur much more often, maybe once in a week or so. If the stars were a bit larger in size, there would be 2 types of eclipses. Every now and then, a smaller star would block the larger one, but only partially. But when the bigger star blocked the smaller, it would result in a total solar eclipse, complete darkness. 2 suns would mean days would become brighter. Nights, sunrises, sunsets, these would change too. The star would set and rise at different times. So, arriving too late to watch the sunset? It wouldn't be a problem. You'd still be in time for the second one. With 2 suns, the seasons on Earth might also start to change more rapidly. They would be harsher than now. Most life forms on the planet would be struggling to keep up with intense and fast climate changes. But returning to the combined gravity that would be stronger than what we have now. Because of this, everything on the planet's surface would look different. Trees would be thick and short, plants stiff and tough. Animals would be way bigger and sturdier. Their legs would be more massive to support their weight. It would increase due to the stronger gravity. People would most likely be bulky and short. Their bones would be thicker, either to withstand higher gravity or because of constant breaking and healing. Humans would also have stronger muscles, lungs, and hearts. Well, at least the gravity wouldn't double at once. If it happened, our planet's core would probably collapse on itself right away. Then it would release so much heat it would burn everything on the surface, like us. Even if the gravity was increasing gradually, adapting to this new world would still be a challenge. Buildings and bridges would collapse under their new weight. Planes wouldn't be able to fly. In any case, discussing what Earth would look like with 2 suns is nothing but a guessing game at the moment. But scientists know for sure that such planets do exist. Kepler 16b was discovered by the Kepler Space Telescope. The planet, the only one astronomers know about so far, orbits 2 stars. It has beautiful double sunsets and is around 200 light-years away from Earth. But this planet isn't a welcoming one. It's the size of Saturn and extremely cold. Kepler 16b is mostly made of gas. It might have a rocky core, but astronomers aren't so sure about that. The planet is also out of its star's habitable zone. That's the area where there might be liquid water. Plus, the stars are colder than our Sun and much smaller. One of them is less than 70% of our Sun's mass, and the other just 20%. That's why scientists are almost sure no life could survive in such a place. It's highly unlikely Earth could be developing in the same way, even if it was orbiting two stars. After all, our planet isn't a gas giant like Kepler-16b. But if this had somehow happened, Earth's fate would be very different now. The temperatures on the planet's surface would be lower than minus 100 degrees Fahrenheit. All water would be frozen, and the chances are Earth would never have turned into the blooming green paradise we live in. At the same time, our Sun might have had a companion long ago. It could be Nemesis, a theoretical dwarf star. If it had been a white dwarf, just a teaspoon of its matter would have weighed more than 5 tons. It's almost as heavy as an elephant. White dwarfs are extremely dense. They can be the size of our planet, but as massive as our Sun. Such a dwarf star could be responsible for several mass extinctions on Earth. Scientists think it could somehow affect objects in the outer solar system. It's the region which is home to giant planets, Jupiter, Saturn, Uranus, and Neptune, and their moons. Anyway, Nemesis could push different space bodies off their course. Then it probably hurtled them toward Earth, where they collided with our planet and caused terrible disasters. It's just a theory, though. Many scientists don't support it, and astronomers haven't found any evidence yet. But a 2017 study suggested such a star could exist in the ancient past. Even better, the researchers claimed each star, like our Sun, was once born with a companion. But even if Nemesis had existed all those billions of years ago, it would have broken free of the Sun's gravity quite early in its history, and then it would have wandered off into the Milky Way.
It was September 2nd, 1859. People all over Europe and North America woke up at night, confused and still tired. They were sure it was already morning. It was so bright outside. But when they looked out of their windows, they discovered it wasn't sunlight. The skies were lit by countless intense auroras, red, green, and purple. They were so brilliant, one could read a book as easily as in the afternoon. Auroras appeared even in the regions where they had never been witnessed before, like Cuba, the Bahamas, Jamaica, and Hawaii. Cool visual effects weren't the only thing that both mesmerized and horrified people. The most high-tech stuff at that time, telegraph wires, shorted out throughout Europe and the US. Sparks were flying from equipment, and many human operators got electric shocks. Papers in telegraph offices burst into flames. All the machines were immediately disconnected from their batteries, and still, they mysteriously kept sending broken messages. Fires, ignited by short circuits, spread over large areas. Colorful lights kept dancing overhead. All this caused panic and total confusion. Earth's inhabitants had never seen or experienced anything like that before. At that time, very few people knew that the Sun was to blame for the chaos. One of them was English astronomer Richard Carrington. At about 11 a.m. on September 1st, the man was standing by a telescope in his private observatory. He was watching sunspots on the surface of the Sun. Suddenly, 2 patches of intense white light broke out. They looked as bright as direct sunlight. At that moment, the astronomer didn't know what a terrible commotion these flares would cause. Later, it became clear that the Sun had produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Wave after wave of charged particles slammed into Earth's atmosphere. The planet's magnetic field wasn't powerful enough to stop them. It gave way, and the storm hit Earth, causing havoc. The phenomenon got the name of the Carrington Event. So far, it's been the worst solar storm ever recorded. Good thing it happened when people didn't have advanced technologies and weren't that vulnerable to the Sun's geomagnetic fury. The 1859 solar storm was 3 times more powerful than the one that happened on March 13, 1989. 3 days before it began, astronomers watched a massive eruption on the sun's surface. Within a couple of minutes, a billion-ton cloud of gas was hurled away from the star. It rushed straight toward our planet at a speed of millions of miles per hour. On Monday the 12th, the huge mass of solar plasma reached Earth's magnetic field. This storm was so fierce, it lit spectacular auroras and created underground electric currents beneath North America. These currents must have found some weaknesses in the power grid of Quebec, Canada. In less than 3 minutes, the entire city lost power. Millions of people found themselves in pitch-black streets, dark buildings, and stuck elevators. They woke up in freezing cold homes, unable to cook breakfast. The following 12-hour blackout closed businesses, airports, and schools. The Montreal Metro was also shut. In the US, hundreds of power grids started to have problems minutes after the storm hit Earth's surface. Luckily, none of these issues led to a blackout. The storm was severe enough to disrupt satellite communication systems and radio signals. Some space satellites tumbled out of control for a few hours. Lots of them had mysterious problems that went away as soon as the storm began to subside. No newspaper mentioned it, but in 2012, Earth had a close shave after narrowly missing an extreme solar storm, the most intense in the past 150 years. On July 23rd, astronomers at Space Weather Prediction Center in Colorado spotted 2 clouds of energetic particles. They erupted from the sun's surface and barreled into space. Just 19 hours later, these clouds zoomed past the spot our planet had just left. If the solar eruption had happened several days earlier, Earth would have ended up in the line of fire. So, what if a solar storm as powerful as the iconic Carrington Event happened nowadays? How much more harm would it cause? Would our life get back on track after such a disaster? Before you learn the answers to these questions, let's figure out what a solar storm is. The sun is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can speed up to more than 600 miles per second. The most powerful volcanic eruptions pale in comparison with solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. When people think about danger coming from space, most of them imagine an approaching asteroid, like the one that wiped out the dinosaurs. But apparently, we should be much more worried about our good old sun. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, several days later, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have a mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. Those take ages to replace, especially if hundreds or even thousands get wrecked. In some places, a failure of one power grid would make others collapse as well, creating a domino-like reaction. Picture living without electricity for a day, a month, a year. No light, no computers, no phones, water supply systems out of order, no food in supermarkets. Plus, without electricity, it would be next to impossible to reboot the already failed power grids. A powerful solar storm would cost people $1 trillion to $2 trillion, and that's just during the first year after it happens. It would take the world another 4 to 10 years to recover. The damage to all kinds of satellites alone would reach $70 billion. Under majestic auroras, people would have to get used to a new, dramatically different lifestyle. No doubt, we'd have some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. Once a bad solar storm happens, people would have some time to prepare, between several hours and a couple of days. And if transformers are taken offline in time, the consequences won't be so dramatic. Now, the following news might sound scary. There are also super flares. In comparison to them, our sun's bursts of radiation are small potatoes. Super flares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our sun. It doesn't mean we're safe here on Earth. Even our middle-aged sun knows how to produce super flares, but while young stars can have them once a week or even more often, for the sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one super flare can shred our ozone layer and wipe out life on Earth. The sun isn't technically the center of our solar system. It's in a space called the Barycenter. It depends on which planet you're standing in. The Barycenter is usually closest to the object with the greater mass. So, since we're on Earth, the true center of the solar system is the sun, but not the center of it. With respect to Jupiter, the Barycenter is actually outside the sun's surface. Jupiter is 318 times bigger than Earth, so the balance is different. The planets don't really revolve around the sun, but around their common center of mass. Imagine balancing a pencil on the tip of your finger. You'd have to place it right in the center so that it doesn't tip on each side. Because the pencil has its mass equally distributed, it's easy to assume that everything balances its way like that, especially in outer space. But try balancing a hammer on the tip of your toe. Chances are you'll walk out of here with a broken toe. Its true Barycenter is close to the hammerhead rather than the actual center where you'd grip it. Earth and the sun's Barycenter is like that hammer. The center of mass is more or less in the center of the object. Realistically, if the sun were to rotate around Earth, then our little blue planet would have to be just as big as the sun, or bigger. We can't disregard the other planets in our solar system, which means they all will have to rotate around us as well. But in the ancient days, bright minds always thought everything revolved around the Earth. They called this the Geocentric model, and this made sense to them because it looked like everything above us was spinning around us. The sun and the moon played vital roles in human history, and we didn't feel insignificant in the universe until way later on. In ancient Greece and the Middle Ages, the big brains used the geocentric model to study space. It wasn't until the 16th century that that model changed. Back in those times, they couldn't even imagine that everything revolved around the sun, and they didn't have the knowledge to back any of this up. The Earth can't be the center of the solar system because it's not large enough for the job. For the conditions to suit the enormous size, life would have evolved differently. We'd probably be less dependent on oxygen. Some animals, like whales and dolphins, can stay for hours without taking a single breath. They can even sleep underwater. So the humans of the sun-sized Earth would have specialized lungs and wouldn't need to constantly be taking in air. It means that the plant life would be limited, with just a few shrubs here and there. There are trillions of trees around the world, but the main contributor to producing oxygen is the algae in the ocean. With such vast real estate of oceans and seas, the algae sitting on top are pumping out the air we breathe. Oxygen wouldn't be so abundant on this planet, but our breathing mechanisms might rely on carbon dioxide, another common gas found on other planets. If the planet is hot, then water will be scarce. We would only find it on certain parts of the planet, like mountaintops. The ground would be too scorched for anything to survive in properly. We can forget about seasons as well. The sun is currently just large enough to give us what we need. But since the Earth would be so large, and the sun would be another celestial body emanating heat, we'd always feel like we're inside a microwave. The days and nights will be different, and not much precipitation will happen. With so much heat produced in the core, earthquakes and volcanoes would likely erupt all the time. The surface would practically be a scorching plain of red magma floating around. This would be the true red planet. But if we had the same landscape like on Earth, living somewhere near the mountains could save you. The mountains would still be embedded in the core, but it would be better than staying on the ground. Some of the mountain peaks could even be 100 times taller than Mount Everest. The canyons could be so deep that the Mariana Trench would feel just like a little rupture. Animals would also behave and look different. Cold-blooded animals would have to soak up as little sun as possible so they don't burn. Animals would have to rely on migration to find water in distant lands. Birds can fly for hundreds of miles for migration season, so we'd probably see certain sleek-looking birds speeding through the air. But because gravity would be so strong on the colossal-sized Earth, the flying animals would need thinner bones and a thinner core just to take flight. The real survivors would be the microorganisms. They can live in extreme temperatures and pressures, and can live without oxygen for a good while. The nights would be dark since there wouldn't be any moon to reflect the sunlight. The moon would most probably be on the opposite side of where the sun is shining, so it would forever be a floating ball in the sky. The Earth's rotational speed is the fastest at the equator, so if all the planets and the sun rotated around us, then our rotation wouldn't be so significant. New weather patterns wouldn't be good for crops. Humans would have evolved differently from what we are like now. We'd probably be shorter and stockier since gravity is so strong. And because of the soaring temperatures, we'd probably live in caves all around the world. The strongest ones would have migrated to the mountains. We'd probably have the same evolutionary path as we do now, but other physical features might be different. Our pigment would likely look different to combat the heat. The desert fox has large ears for hearing out predators and for cooling itself down in the scorching desert heat. It's possible that we would also have bigger ears than what we have now for the latter reason. We'd be a lot stronger than we are, and our bones would be thick and tough to break. Gravity is one of the key components to developing our bone density and muscle mass. This means we would unlikely need tools for hunting. This would have delayed the Bronze Age and modern civilization as we know it. With little vegetation, standing upright wouldn't be so necessary to find predators around us. We wouldn't be the fastest runners either, but we'd be strong enough to fight off a pack of strange-looking wolves. And if the Earth was supersized, then it's possible that multiple species of humans would be roaming the land in isolated areas. Some human species would grow and evolve into the intelligent thinkers of today, but some would remain the same. And some creatures from the past would still be around, unchanged. Sharks would have been around since the dinosaurs era. They wouldn't have to change their form or adapt because of their dominance. Other animals would remain the same because of their isolation. The Galapagos Island hosts some unique animals because they've been alone for so long. Without proper predators constantly lurking around them, they don't fear humans. The new mega-sized Earth would have areas as large as Asia filled with isolated animals that could remain the exact same as when they first appeared. The human species of those regions would also remain the same, since they wouldn't have moved or experimented with anything. Their diet would remain the same, and they would get used to the climate they're in. Technology would also have flourished differently in various parts of the planet. With some areas in complete isolation, they wouldn't have access to new gadgets and inventions. It would be like living on a planet with different eras in the present day. Other areas would be so advanced, they might even be flying themselves outside the planet in search of truth and answers. Our gravity is good enough for us to live properly and develop life, but if we pumped up our size to that of Jupiter, then gravity would crush us. And being the size of the Sun, Earth wouldn't even be a planet, but a brown dwarf, and would constantly be burning until it became a new sun. As of now, Earth is so small in our universe that we're practically like a grain of sand in the desert. On a cosmic level, we're an insignificant contribution to this universe.
The Sun is getting ready to flip as its magnetic poles are reversing. Similar to Earth, the Sun has a magnetic north and a magnetic south. But unlike Earth, the reversing process of the Sun's poles is more frequent and easier to predict. The next flipping is expected to take place this year between April and August. As apocalyptic as it might sound, you don't have to worry. If you're around 30, you've already experienced this phenomenon more than once as the Sun flips every 11 years. You probably didn't notice any changes back then because this process doesn't impact Earth's life so much. But this time, things might be a little different. On Earth, ocean currents are movements that play a crucial role in influencing both climate and weather by distributing heat from the equator to the poles. On the Sun, these currents are more like an ocean of plasma, but they not only transport heat, but also carry electromagnetic energy. That happens because the Sun is a huge ball of hot and ionized gases that keep flowing inside its core. By fusing together hydrogen atoms and forming helium, our star releases a massive amount of energy, leading to these very heavy flowing electric currents. And whenever you have currents, you have magnetic fields. It's easier to understand if you think of that classic experiment with a wire and a nail that you probably conducted in elementary school. When electricity flows through a wire, it creates a magnetic field around the wire. So when you connect a wire to a battery and wrap it around a nail, the nail becomes a magnet. This is similar to how electric currents create magnetic fields on the Sun. This whole process, with the help of which the Sun generates its magnetic field, is called a dynamo. We can't observe it directly, but we can see its effects on the Sun's surface. When plasma and magnetism flows become unstable and intense, they manifest as sunspots. You know, those dark areas on the Sun's surface? Much about how the dynamo works remains a mystery, but scientists have learned something important after observing these sunspots for centuries. The dynamo process follows a pattern. About every decade, it reorganizes itself. The Sun's polar magnetic fields get weakened, eventually reaching zero, and then they return, but with the opposite polarity. Back in the 50s, researchers figured out that when sunspots start to ramp up and become more intense, it means the poles are gearing up for a reversal. And over the past few years, solar activity has been off the charts. We're talking about more solar flares, more electromagnetic radiation bursts, and more plasma blobs being ejected into space. It's like we're sitting in the front row at the solar system's most epic fireworks display. In fact, the Sun hasn't been this lively in probably 2 decades. Right now, experts think the polar fields are almost in sync and steadily weakening, inching closer and closer to zero. But we haven't reached the point of reversal yet. Although it might sound like the Sun flips its magnetic poles like clockwork every 11 years, the truth is that it's not as neat as it seems. This path can be bumpy, and some aspects of the phenomenon are still very hard to predict. Take the last solar cycle, for example. The Northern Hemisphere started its magnetic flip back in early June 2012, but then it kinda hit a snag and lingered around the neutral point until late 2014. Meanwhile, in the Southern Hemisphere, things were smoother, with the polarity switching over in mid-2013. This time around, the sun is actually playing nice. Things seem to be running way smoother this cycle, with the poles transitioning more evenly. But here's the thing, reversal processes are never the same. That's what makes this phenomenon so interesting to observe. But at the same time, it's hard to predict how it'll affect us down here. Here on Earth, we don't have to worry too much about those intense sun explosions happening 93 million miles away. But if, and I emphasize if, a solar storm were to reach our planet, the main threat it would bring would probably be the disruption of communication satellites in space. However, things might be different in this cycle reversal happening in 2024 because the number of satellites has skyrocketed in recent years. For example, Elon Musk's Starlink system alone involves more than 4,000 of them. All these satellites, along with communication and GPS satellites, could be impacted or even destroyed by a powerful solar storm. Although the chances of a powerful solar storm hitting Earth are low, it's not impossible. Back in 1859, during the Carrington Event, a storm occurred near the peak of the solar cycle, causing currents to surge through telegraph lines, sparking fires and disrupting messages worldwide. Earth fell silent as telegraph communications failed. Just imagine what a solar storm could do to our vast number of satellites today. It could affect everything we rely on daily, from space-based communication and navigation to weather forecasting services. The ground-level power distribution could also be affected. You can forget about watching YouTube or Brightside, because if such an event occurred today, it would cause an internet apocalypse, sending countless people and businesses offline. There's a prediction that says that if a Carrington-class event happened today, it would result in damages ranging from $0.6 to $2.6 trillion. And I'm talking about the United States alone. Fortunately for us, solar storms as intense as the Carrington event happen only once every 500 years or so. Bad news for communication satellites, but great news for aurora watchers. During the Carrington event, dazzling auroras borealis lit up the sky as polar light shows stretched far beyond their usual ranges. The northern lights were spotted as far south as Cuba and Honolulu, Hawaii, while the southern lights were seen as far north as Santiago, Chile. For many people around the world, this was their first glimpse of the aurora, leaving them obsessed with the unusually bright skies. Some of them thought it was the end of the world, while others began their day early, thinking the sun had risen after hearing birds chirping and seeing the bright skies. Today, we know there's nothing strange about it, considering that the appearance of auroras at lower altitudes is one of the expected effects of the sun's magnetic pole reversal. Typically, these dazzling phenomena are found between 60 and 75 degrees latitude, but during the last magnetic pole reversal in 2013, intense auroras were observed below 50 degrees. Eyewitnesses describe these auroras as blood or deep crimson red, shining so brightly that you could read a newspaper in their light. It's important to study this phenomenon and not to fear it. The inversion of the magnetic poles on the sun is actually a great opportunity for scientists to better understand how our star works. Since many pieces are still missing in the whole dynamo situation, we're still not very good at predicting why some solar cycles are more intense than others, or when exactly a coronal mass ejection will erupt. But being able to predict that is becoming more and more necessary as we venture ourselves into space. The more people are out there beyond Earth, the more exposed they are to these strong solar storms. That's why the scientific community wants to know more precisely when a solar storm can cause damage to spacecraft and space stations. Plus, it would help meteorologists make progress in predicting weather, not only on Earth, but also in space. The whole point is to make space travel safer as the interest in crewed missions to the Moon and Mars grows every year. Another reason why it's important to learn more about the sun's pole inversion is to better understand how the mysterious interior of the sun works. That could actually help us figure out the aspects of other stars in the universe and maybe get closer to answering the ultimate question: why are we here?